So in general, chapter 6 is about quadrilaterals. We are starting this chapter with talking about polygons in general. So quadrilaterals will be the focus after we get past lesson 6.1, but right now we're kind of talking about polygons in general. Remember, the word polygon means many sides. A polygon is a shape that's made with segments. It's closed, the segments won't overlap. There are some kind of requirements, but all of the geometry shapes that you think about, triangles, squares, quadrilaterals, pentagons, whatever, those are all polygons. Okay, here's a term we have not talked about, I don't think. A convex polygon. So there's two types of polygons. Oops, sorry, it's too slow. I don't want that to look so pretty. Yeah, it wants me to make it look pretty. This is convex. So the reason it's convex, there's like a definition here that says no side that's extended will intersect interior points. Okay, if you stretch out this side, you don't hit any points on the inside of the polygon. If you stretch out this side, you're not hitting any points on the inside of the polygon, right? Do you remember that you can actually draw a dotted? I never think to do that, but did you know you can do that? So if you stretch out a side, it's never going to hit interior points, okay? That's called convex. Another way to think of convex is that it's pushed out everywhere. So there are no indentations. If you put a rubber band around a shape that, like a rectangle or that type of quadrilateral there, what would happen with a rubber band if you put it around that shape? What would a rubber band look like? It looked like that, right? A rubber band put around it, it would just touch, like it would just snap around it like this, right? It would touch all the vertices, it touch all the sides. Put a rubber band around it, it looks just the same. Okay, that's called convex. The other one, do you guys know what the other one's called? Concave. So here's a concave shape. It doesn't matter how many sides it has. Okay, but this one is concave. And you can think of that kind of like caving in. Did we talk about that before? Okay, good. So what happens with the rubber band when you put a rubber band around that? Yeah, so here it's gonna snap to it, right? What happens up at the top? It'll go straight across like that, okay? So if you put a rubber band around a concave polygon, it's not gonna snap to it. It's gonna leave gaps like that. So anytime that it's caving in, that's a concave polygon. Okay, a term that, so we're basically going to be talking about when we do the angles and polygons, we're going to be focusing on convex polygons. A diagonal, here's a picture of a diagonal. You need to have at least 4 sides. Oh, gosh. I didn't want it to look like anything special. A diagonal is when you pick a vertex and you connect it to any other non-consecutive vertex. Okay, so in this picture, how many vertices are non-consecutive? That means it's not already touching. Just one, right? Can't use this one because it's already connected with the vertex that I marked. Can't use this one, it's already connected. There's only one non-consecutive vertex. When you connect those, that's called a diagonal. So hopefully that's obvious that the more sides there are, the more diagonals there will be. But from that one vertex, there's only one diagonal. If I chose this vertex, how many diagonals would I get from that vertex? Just one. Okay, so there's only 2 ways to draw diagonals in that quadrilateral. Just leave that red segment. I don't want that other blue in there. Okay, but from that vertex, from this vertex, there's only one diagonal because there's only one non-consecutive vertex. Okay, we're going to use that idea to talk about, kind of try to figure out a formula. So the number of sides, what's the fewest number of sides you can have in a polygon? How many? Fewer. 3, right? What's a polygon with 3 sides? Triangle. So you can have 3 sides in a polygon. There would be 1 triangle there. What are the some of the interior angles in a triangle? 180, right? Okay, so here's a triangle. How many diagonals does a triangle have? How many? Yeah, none, right? There are no diagonals because every vertex is connected to every other vertex. If I try to draw a diagonal to a consecutive vertex, there are no consecutive vertices. Okay, so that one is just 180 degrees. All right, number of sides. If there's 4, so I'm going to write terms over here also. You know that 3 sides is called a triangle. 4 sides is a quadrilateral. Oh, I shouldn't have said that. I was supposed to ask you that. Okay, so if we have a quadrilateral, jump over here to the quadrilateral. From one vertex, it doesn't matter which vertex you pick, but from one vertex, I'm going to grab that vertex right there. It doesn't matter which one you pick. Kendall, how many diagonals can I draw from that one vertex? Just 1. That's the only one that's not already connected. How many triangles did we just form? 2. Okay, so when you draw in your one diagonal, you get, and I'm only doing it from one vertex. Okay, I'm not drawing in all the diagonals. I'm just picking one vertex and drawing the diagonals I can make to split it up into triangles. So if there's 2 triangles there, what's the sum of the interior angles in that quadrilateral? 360, right? Each triangle is 180 and there's 2 of them. That's going to be 360. Okay, what do you call a 5-sided polygon? Pentagon. Building in Washington called a pentagon. Okay, so find the pentagon over here. Pick a vertex, any vertex, Kara. What we're trying to do is figure out, I should have said this, we're trying to figure out, you know that in a triangle, all the angles add to 180. Now we know in a quadrilateral, they add to 360. If I gave you like a 10-sided polygon, what would be the sum of the interior angles? So we're trying to figure out a formula for that. So basically we're cutting it into just triangles, like the simplest triangles that we can. So that's just creating 2 triangles, okay? On this one, pick a vertex. Again, it doesn't matter where you start, but we're drawing the diagonals from that one vertex. 2, 1, 2. How many triangles, Diamond? Okay, 2 diagonals, 3 triangles. So if it is a pentagon, you'll get 3 triangles. Each triangle is 180. That's going to be 540 degrees. Okay, we'll do one more of those. Hopefully we're seeing some kind of pattern here. What do you call a 6-sided polygon? You want to, Remember when I said if I wanted to draw it from the other vertex? So like just the definition of a diagonal is pick a vertex and connect to a non-consecutive vertex. So up here, that would also be a diagonal, okay? But then I said get rid of it because I'm just trying to show you the definition of a diagonal. So if I wanted to draw all the diagonals, like you would have to, on this one, you would have to then go to this vertex and draw in those diagonals. And then you would have to go to this, let's see, that's already connected. This one is not connected to that one. I think I got all of them now, right? So if you drew in all the diagonals, that would make it kind of more complicated looking. I'm just trying to cut it down into triangles. That was what Kara asked. Why didn't I draw all of them? I'm just trying to think about splitting it into triangles. Okay, so 6 sides is a hexagon. How many triangles do you think there should be? 4. What's the pattern you're noticing? Going up by 1, right? So 4. So here's a hexagon. Pick a vertex, doesn't matter where you start. Pick one vertex. How many diagonals? 3. How many triangles? 4. Okay, so your sum of all the interior angles, it's 4 triangles. So 720 degrees. Now, n, when we talk about the number of sides in a polygon, we use the letter n to represent how many sides there are. What I'm looking for is a formula, okay? If I gave you a generic n number of sides, I want a formula that I can plug into to figure out what the sum would be. So if I say, okay, it's a 12-sided polygon, I don't want to have to make a table going 6, 7, 8, 9, 10. Like I don't want to have it rely on the previous answer. I want a formula I can just plug it into. So I want you to think about the difference, not the difference, but the relationship from these numbers to those numbers. What's the relationship? You're subtracting 2, right? And these are the numbers. These are the numbers that are showing up in the front. This is like 1 times 180. So that means that if this number here is n, oops, sorry, this number there is n, then this expression should be what? You said we were going to subtract 2, so it should be what? N minus 2. Okay, so if it has n sides, the number of triangles would be 2 less than that. So if there were 10 sides, there'd be how many triangles? 8. And then what's the formula over here? Well, whatever this was, that got multiplied by what? By 180, and that's your formula, okay? We call this an n-gon. Okay, so 3 sides, it's a triangle, 4, it's a quadrilateral, 5, it's a pentagon, 6 is a hexagon. Let's go ahead and finish off the vocab that you're gonna need to know. Do you remember what you call a 7-sided? This always gets people. It's a heptagon. Okay, it's a heptagon. 8, that one we usually know. Octagon. 9, do we know that one? Nonagon. Take notes. 10. What is it? Decagon. Deca, like decade, means 10. Okay. 11, it's quite possible you've never heard this. Undecagon. I don't think I even heard that term until like a couple of years ago. But in Latin, UN means 1, is that right? It's like somehow related to like a Latin name. These probably are all Latin names, really. I don't know Latin, so. And then 12 is one you probably have heard. Do you remember what 12 is? It's related to a decagon. There's a prefix to it. Dodecagon. Good. Okay, so that's a vocab. You need to know those because if a problem is talking about a nonagon, you have to know what that means 9 sides. Okay, so make sure that those are vocab words that you know. Okay, triangle, obviously that's pretty easy. Make sure that you know these. Okay, so back to the formula. If your polygon has n sides, the sum of the interior angles is 2 less than that number multiplied by 180. Okay, this is a formula for the sum of the measures. The sum of the measures of the interior angles. It's an n-gon, so there's n sides. N minus 2, the quantity n minus 2 times 180. N can refer to the number of sides or the number of vertices. So if you think about like a triangle, for example, a triangle has 3 sides. It also has 3 vertices. How many interior angles does a triangle have? 3, right? There's 3 angles on the inside. At each vertex, you could also create an exterior angle there, and an exterior angle here, and an exterior angle there. So it would also have 3 exterior angles. So when we talk about n, okay, n refers to the number of sides, the number of vertices, or the number of angles when you look at one of each vertex. So n is used in different ways depending on what we're talking about. Okay, so what if you knew it was regular? I don't think I've given you this definition before. Does anybody know that term, regular polygon? I don't think we've talked about this. A regular polygon has all of its sides the same length. What is the word that means all the sides are congruent? It's something, equilateral. That means all sides are congruent. If you know that term, you don't have to write that all sides are congruent. And do you know the term for all the angles are congruent? Equiangular. Good. Who was that? Good. Equiangular. Okay, that means all the angles are congruent. So that's regular. Now, do you know what a regular quadrilateral looks like? Let's start with triangle, actually. What does a regular triangle look like? That, right? What are the angle measures going to be? 60. So an equilateral triangle would look like this, and all the angle measures have to be the same, so they'd all be 60. Right? Because they have to add up to 180 divided by 3 equally 60 degrees. Okay, that's like an equilateral triangle or equiangular triangle. Okay, how about a quadrilateral that is regular? It has to have 4 congruent sides. What will the angle measures have to be? And why are they 90? Yeah, they have to add up to 360, and it's regular, so all the angles are the same. When you take a fourth of 360 or divide 360 by 4, that makes all of those angle measures 90 degrees. Okay, this is, what's that shape? A pentagon. That's a regular pentagon. Okay, all of these in this picture over here are regular. Because again, all the sides are congruent. You can see that because it's shown on the picture. They've shown you all the sides are the same. Right? They've shown you all the angles are the same. And that's a pentagon. What is the sum of the angles in a pentagon? 540, right? We figured that out up here. Okay, so in a pentagon, when there's 5 sides, you subtract 2. Here's the formula. Oops, sorry. Here's the formula. You take the 5 sides, it would be cut into 3 triangles. And it adds up to 540. Since it's a pentagon, you would be dividing that by what? 5. And that would tell you each angle is goes in once, 108. Okay, now that's because it's regular. If we looked at that quadrilateral, okay, that's not going to have all 90 degrees because it's not a square. Okay, I'm just talking about regular polygons. If it's regular and they're all the same, you can divide evenly that sum evenly into how many angles there are. Okay, this is each angle measure. Each angle in a regular pentagon. If you don't know that all the angles are the same, you won't know how it's split up. You'll still know they add up to 540, but you won't know, is it like 90 on one and 100 on another and 72 on a third? So that's only if it's regular. Okay, so that's where right here it says the measure of each interior angle, the measure of each interior angle of a regular n-gon. Now again, remember n means how many sides, vertices, or angles there are. So n being 3 means it's a triangle. Then as 4, it's a quadrilateral. Then as 5, it's a pentagon. Okay, we're going to do the same thing as we did up above. N minus 2 quantity times 180. That finds the sum of all of the interior angles. Okay, and then what are you dividing by? So we're trying to find the measure of one of the angles in the regular polygon. Here we did 180 divided by 3. The whole sum is 180, we divided by 3. Here our sum was 360, we divided by 4. It's n because why? How many sides? Yep. It's also the number of angles, right? So on a triangle, n equals 3. On a quadrilateral, n equals 4. On a pentagon, n is 5. And again, n can be either the number of sides, right? 1, 2, 3, 4, 5 sides. Or it can be the number of vertices. 1, 2, 3, 4, 5 vertices. Or it can be the number of angles. 1, 2, 3, 4, 5 angles. Okay, so Jake said it. Somebody else tell me what goes down here? N, because it's representing the number of sides. And you can say number of sides or number of angles, whatever you kind of makes sense to you, but you're dividing by n. That's a fancy way of just saying, you know, what we did over here. This is what that is. This is n minus 2 times 180 divided by n. So here's the whole formula. And again, this is only if it's regular. This formula is only if it's regular. If it's not regular, you don't know how the angles are split up. You just know what they all add up to. Okay, I'll zoom out there for a second. Now, first thing you want to do in the next problem is figure out how many sides there are, and then what? There's how many sides? 5. Okay, that's a pentagon. Sum of the interior angles is what? 540. And if you didn't remember that, okay, you don't have to memorize that because you could do 5 minus 2 times 180, which is 3 times 180, which is 540. Okay, if you don't remember that it's 540, you just figure out what it is. Now in the chart up there, we did, you know, we filled it in and we got 540. So that means these are just like those problems where you had a triangle, you added up the angles equal 180, except that now it's going to add up to, not going to add up to 180, it's going to add up to what? 540. Okay, so Lily, tell me what the equation should be. For this one, just add them all up. Just tell me like what is it going to be? What are we checking? If it was a triangle and I said this was 20 and this was 7x and this was x plus 8, what would your equation be? Plus 56 plus what? Okay, it's a pentagon, which means there's supposed to be 5 angles. You're missing one. Plus 90. Don't forget about that guy right there. That's 90. I would recommend, and I know what you did is you were adding the numbers and then putting the X on there. I would recommend that you kind of go around in order because you don't want to miss any of them. Okay, so if you go, okay, 120, 90, 151, 56, and then X, you won't miss any of the angles that way. It's going to be the same thing in the end, but kind of what I would recommend. Okay, let's see. Oh, what did that say? Okay. Okay, 120, 151. Your calculator is going to be your friend on these problems. Okay, 417 plus X is 540. $540 minus Oops, let me do that. 540 minus the answer, 123. Okay, what if instead of being a pentagon, what if there were 8 sides? Instead of this adding up to 540, what would it add up to? How would you find it? Yeah, so if it was an octagon, you would do what times 180? 6, right? 2 less the number of sides. If this was an octagon, you would make it equal to whatever that is. I don't know. Okay, so that number over there is going to change depending on what the shape is. Again, you knew if it was a triangle, you add it up to 180. Whatever the shape is will tell you what to add it up to. Okay, now something that's helpful for what we're going to do next is the fact that at every vertex, so let's just draw a little shape down here. It doesn't matter if it's a triangle or what, so I don't want it to look like a special triangle. It still kind of looks, there we go. At every vertex, if you stretch out one of the sides, okay, I'm going to stretch out just one of the sides and look at the angles in here. So let's say that this was like 20, oops, sorry. Let's say that that's like 20 degrees. What would the angle out here have to be? 160. Because they're what? Yeah, what is it when they're supplementary and adjacent? Linear pair. Okay, let's say this one was 70 degrees. What would the angle out here have to be? 110. So at every vertex of a polygon, those angle measures have to add up to 180. And that's something that's going to be helpful. Okay, those are always going to be supplementary. The interior angle, that's the exterior angle. It's always going to add up to 180. Now, we just got done talking about how you find the sum of the interior angles of a polygon. Okay, let's kind of use the triangle here to see if we can kind of see what's going to happen with the exterior angles. If I told you 20 and 70 were those two angle measures, what does the last angle measure have to be? Okay, because they got added to 180, right? And this exterior angle would then also be 90. If I add up, I don't want to change colors there. Let me go back to what I was doing before. Whoops, lost my triangle. If we add up all the exterior angles, so let's just look at the exterior angles here. This angle, and this angle. 110, 90, and 160. Add up to how much? What's 110 and 90? Yeah, 200 plus 160 is 360. Okay. If it was a quadrilateral, let's say you had 4 sides, and it was, let's say that it was a square or a rectangle where those are all 90. Okay. The exterior angle measures down here would be how much? 90. 90. You did that all the way around. The exterior angles would be 90. What's the sum of the exterior angles in that square? 360. Okay, that is not a coincidence. When you add up all those angles on the outside, the exterior, you again get 360. That's for any shape. That's why the exterior angles are so much easier to think about than the interior angles. Okay, in every convex polygon, the exterior angles will add to 360. So instead of having to go and like figure out, like you do with the interior angles, how it's going to change every time, As the number of sides increases, what happens to the sum of the interior angles? As you increase the number of sides. So like if this is 100, if n was 100, if there were 100 sides, it's getting bigger and bigger and bigger and bigger and bigger, right? The more sides there are, the greater the sum of the interior angles is. But the exterior would still be 360. Okay, so the exterior angles are a lot simpler than the interior angles. Sorry about this random little squiggly there. You can hide it if you're OCD like me. Was Blair the one that called me OCD? I can't deny there's a little bit of that. Okay, the sum of the measures of the exterior angles. Now I want to remind you also what an exterior angle is. Remember that an exterior angle is when you just extend one side of the polygon. So this is an exterior angle, and that's an exterior angle. Okay, so all of these angles here are exterior angles, 3 and 4 and 5. Actually, let me not circle them. Let me do this. Angle 3 here, angle 4 there, angle 5 there, angle 1 there, angle 2 there. Can you think about if you were to stand here and, you know, kind of facing along this direction, if you walked this side and then rotated, and then walked to this side and then rotated, and then walked this way and rotated, and walked this way and rotated, and then walked back up here. Can you see how that's 360-degree rotation? Ryan, why? What is? Yeah, it's an entire circle, right? If you stand forward and you do 5 rotations all the way around and come back to where you were, you've gone 360 degrees. Okay, that's why that makes sense that the sum of the exteriors is always 360. Always, 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 no matter how many sides there are. Okay, the exterior ones are nice because it doesn't rely on number of sides. It's always 360. So if I'm like, it's an octagon, what's the sum of the exterior angles? 360. It has 800 sides, what's the sum of the exterior angles? 360. Okay, the sum of the exterior angle measures is always 360. It doesn't change with the number of sides the way the interior does. The exterior angle is always out of 360. So that means if it was a regular n-gon, again, regular means what? All sides congruent and all angles congruent. Equilateral and equiangular. That's an and. Okay, so the measure of each exterior angle, if we knew that this was a pentagon, for example, and it was regular, if this was a regular pentagon, what would each angle measure have to be? How do you find that? (360) divided by 5. Right, there's 5 congruent angles, so 360 is divided evenly into 5 congruent angles. And that's how much? 72. Yep. So if it's not regular, you don't know, again, how the 360 is broken up. But if it's regular, it's the same thing as before, except that it's easier because the sum's always 360. Okay, 360 divided by n. Again, 360 is the sum of the exterior angles. N is the number of sides or the number of angles, whichever way you kind of like want to think about it. It's both. Okay, let's look at the next problem. Also a random, I must have, yeah, here, I'll get rid of it for you. I have a magic eraser. Is that better? Okay. All right, so here is a polygon. How many sides are there? Oops. Okay, there's 5 sides. Braden, is that regular? Because why? Okay, all the exterior angles are not what? They're not what? That's true, but regular means all the sides are the same and all the angles are the same. Are all the angles the same? No. So that's not regular, okay? But it says they want you to find the value of x. So we're gonna do the same thing as one that Lily told me. We're not gonna stop. 2x minus 12, 32, 2x, x, and what would be the exterior angle down here? 90. Make sure you don't forget. If it's a pentagon, there's going to be 1, 2, 3, 4, 5 shapes. Now, when I add that up, what does it add to? 360. Why is this one different than the one up here? Why this time is it 360, not 540? They're what? That's the interior angles, right? That's the interior angles. This one was also not regular diamonds. This time we're looking at the exterior angles. Okay, all of these guys are exterior angles. So exterior angles always add to 360. Always, always, always. Doesn't even matter how many sides there are. Okay. So this one you're going to have, let's see, 2, 4, 5 x's. 32 minus 12 is 20. Plus 90 is 110. 5x will be 220. Nope, sorry. 5x will be 250. So x is what? 50. Oh, sorry. Okay, now, is that regular? No, all the angles are different, right? This one is regular. So how can you find the value of x? Okay, this one's regular. How many sides are there on this? Wait, how many? Yeah, no, not 5. 1, 2, and I know this seems silly, but it's really easy to miscount the sides. If you're, if you might miscount the sides and just put 1, 2, 3, 4, 5, 6 and count them. Okay, so this is an exterior angle. How do you find its measure? You don't, because we already know that all the exteriors are the same since all the interiors are the same. How many exterior angles are there? But you could do that at every vertex, right? There'd be one here, and there'd be one here, and there'd be one here. Sorry. And there'd be one here, and there'd be one there. There's 6 exterior angles, and they're all congruent, right? That means that one exterior angle would be 360 divided by 6, or 60 degrees. Now, it's true that if you looked at all these interior angles in here, they would have to be how much? They add up to 720. What is the measure of each of them? Yes, and you can also just say if this one's 60 degrees, it has to be 120, right? All those things should kind of go together. These guys have to add to 180. And also the sum of the interior, here's the hexagon. The sum of the interior in a hexagon is 720. So 720 divided by 6 is also 120. Okay, 720 divided by 6 is 120. Okay. Here's what I want you to do. I just want you to try, I'm changing my mind about what I'm assigning. I'm just going to have you do those 5 problems. Okay. There's a summary of all the formulas down here. Because we didn't get to do examples, I just want you to try those 5 problems and see what you can come up with. And I'm going to make that homework 5. Okay. So don't do what's posted. This will be homework 5.